Hi guys, so in this video we're going to be looking at series parallel electrical circuits, and we're going to be looking at how to find the total resistance, the current, how to find volt drop across various banks of resistors or loads, and also how to determine the current through a particular component when it's in a parallel configuration. To help us demonstrate the application of Ohm's law, we will be simulating our circuit in Circuit Wizard. So the circuit we'll be using is a series parallel circuit, and we will be calculating the resistance, the voltage, and the current at particular points in the circuit below. So the objective of this exercise is to demonstrate an advanced knowledge and understanding of Ohm's law and applying it to a more complex circuit than just either a parallel circuit or a series circuit. So in your exam question, you may get a number of points that you have to calculate. So for example, we want to be able to calculate the total resistance of the circuit, the total current that these components will draw, and then we also look at the volt drop across different banks. Okay, so in this case we're going to be looking at the volt drop across bank B. How much of our supply voltage will this bank of resistors drop our voltage? And then also we're going to look at how much current will flow through a particular component. So in this case we'll be looking at through the current through R4. So the first part of our question is to calculate the total resistance for the circuit. Now we've got a series parallel circuit, so what we need to do is we need to apply the parallel resistance formula to each bank, or except for bank C because it's not in parallel, to establish what the combined resistance is of bank A and bank B before we can then add the three together to establish the total resistance. So the parallel resistance formula is 1 over R1 plus 1 over R2 plus 1 over R3, or however many loads you have in a particular parallel arrangement, and then you take the sum of those and you do 1 over that sum, and that would then give you the total resistance for that bank or for that circuit. This is a slightly long-handed way of doing it. There are other methods, but we're going to stick with this method for this demonstration. So applying our parallel resistance formula to each bank, you can see from the workings here that for bank A we would apply the parallel resistance formula, so 1 over 3 plus 1 over 6 equals 1 over 5, so that, or 1 over 0.5, so that 0.5 is 1 over 3 plus 1 over 6, and then that would equal our 2 ohms. So bank A is going to have a resistance of 2 ohms, and then for bank B, same again, okay, but this time we've got 3 components, so we've got 1 over 4 plus 1 over 10 plus 1 over 5, that equals 0.55, and then so you do 1 over that, and that gives us a resistance for that bank of 1.8182. Now at sort of level 3 I would expect you to be working to 3 decimal places, so an answer of 1.818 would be sufficient. Now bank C hasn't got anything in parallel, so bank C is just a 7 ohm resistance rating. Now that we've established the resistance values for each bank of resistors, we can then go ahead and use the series formula, which is R1 plus R2 plus R3 and so on would equal the resistance of that circuit. So adding ours together, so 2 ohms plus 1.8182 plus 7 would give us a resistance reading of 10.8182 ohms, and that would be the total resistance for this circuit. Now that we've established the total resistance for the circuit, we can now go back to our Ohm's law formula and determine what the current is. So we know what the voltage is, so we've got a 12-volt battery and a resistance reading of 10.8182. So 12 volts divided by 10.8182, and that gives us a current reading of 1.109 or 1.11 amps. So just to show that our calculations have been correct, I've simulated the circuit on Circuit Wizard, and as you can see here, by inserting an ammeter into the circuit on this main line here, I can see that the current of this circuit is 1.11 amps. So part C of our question is to calculate the volt drop across section B. So as our current flows around our circuit, the electrical pushing force, so our voltage that's pushing our current and getting it to drive through our components, as it goes through each bank, it's going to drop. So what we've got is we've got 12 volts on this side and 0 volts on this side, and as it goes around, it's going to drop as it goes through the circuit. So we need to calculate how much our voltage is going to drop in bank B. So with our circuit wizard simulations, we can see that by inserting a voltmeter into the circuit, we can see that the voltage is starting to drop as it goes around our circuit. So we can see how much the voltage is dropping as it goes through each bank. And now what we are assuming is that the conductor is at zero resistance. Okay, so that doesn't affect the volt drop. Okay, so what we can do now is we can use our Ohm's Law formula to calculate what these volt drops are going to be. So to calculate our volt drop, we are looking for voltage. So the two parameters that we need are current and resistance. Now in the question it's asking for section B, so technically we only have to answer this one, but as a top tip I would say if you could do all three or however many banks that you have, at least that way you can have a bit of a sanity check to see if your maths is correct. Okay, so we're looking for voltage, so we need current times resistance, and the resistance value that we need for each bank is the resistance for that bank. So the first bank A had a resistance of 2 ohms, so we're going to use that resistance value. So if we look down here, we take our original current, which is 1.109, times it by the 2 ohms, and that gave us a volt drop of 2.218 volts. Okay, so that's how much that bank will have dropped the voltage by. So as you can see from our circuit simulation, what we've calculated in the previous slide is actually correct. Okay, so we've got 12 volts as our supply voltage minus it from what we've calculated, and that gives us a 9.78 volts rounded. Okay, so working to 2 decimal places here, we can see that we've got an accurate voltage reading. Now what we need to do is apply the same process to bank B and to bank C. The reason why we want to do that is because all of the volt drops, okay, that you calculate should add up to your supply voltage. Okay, so if for example in your question paper, if you're getting if you calculate all three and you get a voltage when you add them all up of say 13 volts, 14 volts, or 10, 9, something like that, something quite far off, you know that there's an error in your maths somewhere, so you might have to relook at what you've done. If you're sort of getting 12.01 or something to the decimal point away, the chances are it might be a rounding error. Okay, so as long as you show all your workings, you should be fine. So quickly, just to recap, so if you want to find the volt drop, you're looking for voltage, you need to take the total current for the circuit and multiply it by the resistance reading for that particular bank that you want to find. Okay, so total current times the resistance for that bank will give you the volt drop for that bank. Okay, so the last part of our question is to calculate the current through resistor 4. So we are going to be looking at how much current is flowing through our 10 ohm resistor at resistor 4. So we had a total current of 1.109 amps here. So what's going to happen as the current reaches a node, so this point here, it's going to break up into 2 different directions, and it's going to go through the 2 loads here, come back together, and then break up and go through the 3 different components here. So because current likes to take the path of least resistance, you're going to get sort of higher current flow through R3, and then R5, and then R4 will have the lowest current flow through it. Okay, and so they will all join back up here, so that when we come back to flowing through R6, we would have our total current back again to then flow round back to the battery. We're looking for current. So the 2 parameters that we need is voltage and resistance. So back to our Ohm's Law triangle. So voltage divided by resistance would give us current. So what we need to do is we need to take the volt drop, okay, what we calculated in the previous section for bank B, and divide it by the resistor value for R4. So in this case it's going to be 2.02 divided by 10, and that gives us a reading of 0.202 amps. Okay, so that is going to be how much current is going to be flowing through resistor R4. Now, I said previously about a sanity check, okay, just to make sure our maths is correct, because we don't want to lose any stupid points. Okay, so what I would do is calculate all 3, okay, for that particular bank that you're working with, just to ensure that they add up to your combined total resistance. Okay, if you're getting sort of 0.1 off, 0.2 off, the chances are that's a rounding error. If it's way off, if you're sort of getting sort of 1.5 amps or something stupid like that, okay, there might be an error in your maths somewhere. Okay, so as long as you're working to sort of 3 decimal places, you should be fairly close. So just to confirm that my maths was correct, I did the same calculation again, but changed the resistance value for R3 and R5, and these were the results that I got. So the reason why I did that was just to confirm that the total current that these all added up to matched my total current that I'd calculated earlier. Okay, and as you can see, as the resistance levels increases, the current flow through that component drops. Okay, so R3 has the lowest resistance, so it's the highest current flow through it. R4 is the highest resistance, but has the lowest current flow through it. Okay, so just going back to our simulator, so I've put an ammeter in to measure the current flow through resistor 4, and as you can see, it's coming up with a reading of 201.66 milliamps. So that in amps is going to be 2.02 amps. Okay, so that shows that our maths is correct, and I haven't fed you any lies. So there we go, which is good. So the same process again would apply for bank A, but this time you would only have to do it twice. Okay, so you take the volt drop of bank A and divide it by the resistance of each one of these. So you put the volt drop of bank A, divide it by 3, and do the same again at 6, and that again should add up to the total current that we calculated earlier on. Okay, if it doesn't, there's a problem with your maths somewhere. Okay, so this completes our demonstration on Ohm's law with a series and parallel circuit. So what I would say is go back, change the resistor values from the ones that I've given, keep the circuit layout the same, and just go through the process and practice. Okay, and it should all come together. Thanks very much. Bye bye.